9.5, trig function of any angle. Here's the do now. Find all 6 trig function ratios for the angle of perspective right here. So here's your opposite, adjacent, hypotenuse. Sine is 3 over 5, cosine is 4 over 5, tangent is 3 over 4, and cosecant, secant, and cotangent are the inverse or the reciprocal of each of these fractions. Let theta be an angle in standard position, and let xy be the point where the terminal side of theta intersects the circle, x squared plus y squared equals r squared. So as you can see, here's theta. This is the radius of the circle, and this is the point xy. The 6 trig functions of theta are defined as follows, and I want you to follow along with me. Because we drew this vertical line down to create a right triangle, we can then say that this theta is now over here in the little acute angle right here. So sine is really opposite over hypotenuse. Now hypotenuse is r, that's the radius. And this value here is actually x, and the vertical leg is actually y. Okay, and based on that, we can say that sine is opposite over hypotenuse, which is y over r. Cosine is x over r, tangent is y over x, and cosecant, secant, and cotangent are the inverses or reciprocals of each of these functions. Example 1. Here we have point -4, 3. This coincides with the terminal side of this angle, and it also coincides with the circle. And we've dropped down this vertical line to make this a right triangle. So we're trying to find the 6 trig functions of theta. And we want to know what the legs of the right triangle are, so we can use the Pythagorean theorem to find the radius. So because the x value is -4, this leg is -4. Because the y value is 3, this leg is 3. And some of you may recognize that this is a 3, 4, 5 triangle. For those that don't, you want to plug in the Pythagorean theorem, and as you can see, -4 squared is 16, plus 3 squared is 9, and the square root of 25 is 5. So as you recall from the definition over here, to find all 6 trig functions, we need 3 variable values. We need x, y, and r. So over here we have x, we have y, based on the ordered pair, and we have r, based on our calculation here. So therefore we can go ahead and just place them into the definitions, and we know that sine of theta is opposite over hypotenuse, also known as y over r. So it's 3 over 5, it's 3/5. Cosine is -4/5. I want you to recognize that we're actually using the sine. We have to be sensitive to the signs because we're in quadrant 2. And tangent is -3/4. And the inverse functions are all the opposites of these, are the reciprocal, 5/3, -5/4, and -4/3. The unit circle. The circle x squared plus y squared equals 1, which has a center at 0, 0, and radius equal to 1, is called the unit circle. The values in sine and cosine are simply the y-coordinate and the x-coordinate, respectively, of the point where the terminal side of theta intersects the unit circle. Now this makes sense because the radius is 1, when we divide, or when we have, say, opposite over hypotenuse, whatever the opposite length is for sine, it'll be y divided by 1. And y divided by 1 is just y. And that's why the sine of theta is simply the y-coordinate. And the cosine of theta is simply the x-coordinate. A quadrantal angle is an angle with a terminal side on the axes. Okay, so we have an x-axis, y-axis. Either one of those are axes. That's plural for axis. It is always a multiple of 90 degrees, also known as pi over 2 radians. All right, let's check out this example. Here we have a unit circle. Unit circle means that all these are 1, right? This is 1, 0, this is 0, 1, negative 1, 0, and 0, negative 1. But we want to draw 270 degrees. So we know that 270 degrees, the initial side is right here, and the terminal side, as we go around, was 90 degrees, 180, 270 is down here, straight down. Okay, and the ordered pair right down here, like we already said, would be 0, negative 1. So ladies and gentlemen, we have all of our values, right? X would be 0, Y would be negative 1, and the radius, we don't have to use the Pythagorean theorem for that. The radius is simply, let me just fix this, there we go. And the radius is just simply 1, because we know that in a unit circle, the radius is 1. So there we have that. So now that we have x, y, and r, we can just plug them in to find all 6 trig functions. So here's sine is negative 1, cosine is 0. Now tangent, because we're dividing by 0, it's actually undefined. Cosecant of theta is negative 1. Secant of theta, theta is 270 degrees, by the way, 270 degrees, it's also undefined. Notice the pattern that whenever you have 0 over here, it's undefined over here, and vice versa. When it's undefined with the primary trig function, the inverse trig function is 0. So undefined 0, 0 undefined. All right, let's take a look at stage and scribe number 2. We skipped number 1. Here we have negative 8, 15. We draw our right triangle, so here are the legs. And here's the Pythagorean theorem. We calculate, we end up with 17 as our r. So therefore, x is negative 8, y is 15, r is 17. We take these, we plug them into the definitions of sine, cosine, tangent, and we end up with these ratios. The inverse functions are just the reciprocal of this. Stage and scribe number 3. All right, same deal. Pythagorean theorem, find out that r is 13. X is negative 5, y is negative 12. R is 13. Here are the trig functions. Notice here we have negative 12 divided by negative 5. The negatives cancel each other out. So it's 12 over 5. And the inverse functions are the reciprocals. Finally, number 4, we have a quadrantal angle. Now the quadrantal angle, theta equals 180. Starts off here, this is the initial side, and here's the terminal side. It's a straight angle with this over here, actually I already drew it right over here, is negative 1, 0. All right, so x and y are just the ordered pair that we see, and the radius of a unit circle is always 1. So we plug these in over here, and we see that we end up with 0, negative 1, 0, and that means we're going to get a bunch of undefineds on this side. Undefined, negative 1, undefined. Ladies and gentlemen, there you go. Good luck with this assignment.